Before I forget, those of you who, I think there's 4 or 5 people now, 4 people that are on MyMathLab. The very first couple of assignments on the homework sheets, the MyMathLab won't let me assign anything from the review sections for some reason, so you need to do the e-textbook and actually do those by hand and turn those in. So your assignments start, there's an optional Chapter 6 review for the MyMathLabbers. There's only 4 people I'm talking to right now, so don't worry. You can do that if you want to or not, but the assignments from Chapter 6 on the homework sheet, you need to do those out of the e-text, whoever's on MyMathLab. Yes?
So the homework is under the study plan section on MyMathLab?
No, the homework, like Section 7.1 is on MyMathLab. If you click on that homework, I've already picked out the problems you have to do. You just do all of them. Okay. Chapter 6, the review section, it won't let me assign problems. I don't know why. So you just have to do that one by hand and turn it in. Yeah, the old-fashioned way.
But if we want to use MyMathLab and just do all of it by hand, that's okay?
Yes, totally. If you really want to do that. Well, all right. So you mean do the problems that are in MyMathLab by hand and turn them in?
Yeah, just use the e-text on MyMathLab.
Oh, the e-text. Okay, good. Yes. The other problems, I won't have them, you know, so that's fine. The e-text is fine. Okay. So let's look at this little worksheet. Let me switch it over. There it is. Alright, let's see if I'm okay with technology today. So far, so good, Jeff. Alright. Bless you. Anytime. Aw. We'll try not to hit any extraneous buttons here. Yeah, let's do that. Same thing. So, can somebody, one of those switches controls the lights towards the front? Thanks, man. There it is. Cool. I like it. Review this guy. Boop. Arise. All right, so started us off nice. I tried to. Whenever there's a number out front that's just a 1, it's just a one-step problem, right? Yeah, just have to find the numbers that work. So, of course, what multiplies to be 35 and adds to be 12? Yeah, x plus 5, x plus 7. Keep hands. All right, so let those be nice, right? This guy, 2 terms. There's no GCF. 2 terms could only be what? Could only be...
Binomial.
Okay, 2 terms is a binomial, but what form of factoring could it be? It could be squares or cubes, right? So it's definitely squares. But see, this is how you attack a problem like this. You start to do that checklist. GCF, no. How many terms does it have? What does that mean it could be? That tells you how to attack it, right? So what can how do I attack that then? I like it. So a couple parentheses, cut the y in half, cut the 64b squared in half, plus minus to make the middle term cancel. Kick ass. Right, that's why I call it a thank God problem, because it's relatively easy. If you're going to identify it as a squares, cut everything in half, minus plus, you're done. It's crazy. Alright. So what about this guy? What do I do with 4 terms? Is there any GCF? Any GCF?
Yes.
Okay. No. Somebody manages to take a B out, but does 36 have a B in it?
No.
No, so you can't take a B out. There's a lot of B's, but too bad that last dude didn't have one, so you can't take it out.
Either 2 terms, like making the...
Good, I like it. So 4 terms means grouping. Bam, bam.
And you got the B2.
I like it. So out of the first little set comes B squared.
And B plus 2.
B plus 4. Now I know I need this to show up here, so what am I going to take out of here to make a B show up?
Take out the negative.
Good, negative 9. So now both of these signs are going to change, right?
Right.
B plus 4, thank God. If you do not have the same things here, you can't do another step. What is the next step now?
B is equal to minus Factor the b squared minus 9.
B plus 4.
Kick ass. So this is the next step. And now
The B2 can be removed.
you have to always, whenever you factor, you got to always see where am I at now? Is there any piece of this that can go further? So if I ask you to factor 18 completely and you say 2 times 9, you're wrong because 9 goes further, right? So it's the same exact thing with this. So here,
B minus 2. Yeah, that's it.
And then the B plus 4.
you need all the parts, kick ass.
And then that's
Bam. Let's see, B plus B, B plus 4. So if you multiply all that bad stuff out, you get back to here. Kick ass.
Why don't you put both plus 4 down?
Because there's not 2.
Okay.
I like that. See, I told you I was going to say things like that all the time this semester. There aren't 2 B plus 4s here. So, for example, how do you factor 4y minus by? How do you factor that?
Why?
You take a y out, 4 minus b, right? Because the y would get distributed. So there's not 2 y's. There's one that was distributed. So there's not 2 b plus 4s. There's one that was distributed to both.
Okay.
So you're right, though. I often see somebody put like a little square up there. There's not 2 of them. There's only one that was given to both, right? It's a little bit of a magic trick at all. No. So giving myself another one, come over here. What form is this in, of course?
Cube.
Yeah, there's no GCF, 2 terms. It's only squares or cubes. It's obviously cubes. Right? So what W cubed is W. 27y cubed is 3y, 3y, 3y. And now I just start to populate my little dude, big dude.
You're so.
So little dude, big dude.
Then B plus 3y.
Good. So 1w plus 3y. Little dude only gets 1 of each because he's a little dude. I put 1w there, so I got to put
2.
w squared. I put 1 3y there, so I got to put 3y times 3y is
9y.
9y squared. So now I get my w cubed. I get my 27y cubed. So again, we went over why you can't just stop here. There's extra crap I don't want. So the middle dude is going to be the cleanup dude, right? The guy you call when things go wrong. So what sign is it going to be?
Minus.
So it can cancel stuff.
3y.
Yeah, 3y.
3yw, kick ass. I like it. If somebody put 3wy, is that all right?
Same.
Of course it is, because I don't care what you're doing, you multiply. Normally you put it in alphabetical order, but who really gives a crap? Right? It's fine. So if the book has it the other way, that's, who cares? It's the same answer. How we go? Kick ass. All right? So down here. So always read the instructions. You don't have to reduce these. In fact, you can't reduce either one of these, right? The very first one, what value of x can I not use? 2. So you can pretty much see it. What makes this 0 on the bottom? 2. So you can either say x equals 2 is a value that I can't use, or to be more explicit, you can't use 2. X can't be 2. So either way you say it, I'm cool with it.
Even if you write it in a grammatical way, like 2 is undefined.
Make it more math. Bring it into the other language. Right? Math is another language. Bring it all the way into math language. Because, if you were in 110, I would probably be forcing you to write it like this. Ooh, yeah. But you're fine. You don't have to do that.
The last
X can't be 2 is beautiful.
Last one, Bria took fast.
Oh, yeah? Aw. It's still, anyway, it's fine. You don't need it for this. Part B, what do I have to do? Do I care about the x plus 5? So if that x is equal to negative 5, no, the top can be whatever it wants to be. I focus everything on the bottom, and of course, what do I do to the bottom? I got to see what parts it has, so I can see what makes them 0. So you factor, I like it. Yeah, 10 and 3. Yeah, plus 10 minus 3. Good. And I set that equal to 0, or I set that not equal to 0 even, if you want to. So what are the demands? You can pretty much just see them. X can't be negative 10. X can't be 3. Kick ass. How are we doing so far? All right. So what about this guy? 3a, it's the top. I kind of did this a little bit on purpose. this is the most common mistake, or one of the most common mistakes, is to try to break up the top like this, but you can't. You just can't. It's not a square, so why not?
You can factor
9 is square. 3 squared is 9. But that last x dude is not something squared. Well, it is square root of x, but do you really want to use that? No, I don't. So what do you always try first?
GCF.
GCF. See, that'll save you. If you always think GCF first, it'll save you from making mistakes like that. So what comes out? X. And then you're left with
X minus 3. 9.
and then I know, what you see what I meant earlier about the hint? I know x minus 9 is probably going to be a part of the bottom. Right? And sure enough, I got a 90 there, so that's 9 and 10.
Negative 9.
Good. Thank God it's negative 9 plus 10 to make a positive 1 in the middle, right? So then I can kill I get x over x plus 10. And then I can cancel the x's, right?
No.
No. Good. All right. I like it. Y'all look at me like, now we can? No. You cannot. Testing me, as I do. All right, part B. People pick up on the fact that the top wants to be a cube, but see how I just said it? It wants to be a cube, but it isn't currently, because 2 is not something cubed. Well, nothing nice. 2 is something cubed, the cube of something, but nothing nice. Cube root of 2 is not nice. So what do I do first with the top, of course?
GCF.
GCF. Like always, I try GCF first, take a 2 out, and I get... Now this is a cube. And on the bottom, what can I do?
We take 4 out.
Take a 4 out.
M square.
Yes. All right. Now, anytime there's a cube in a problem like this, there might be a trinomial that is the big dude. And the big dude is never factorable. So when you see a cube in a problem, don't kill yourself over trying to factor all the trinomials, because maybe some of them don't factor. You guys see what I'm saying? That does not factor. That bottom does not factor. It's going to cancel with the big dude of this. So how do I factor this? I can cancel these out, right? So how do I factor the top here? This is MMM. This is
3, 3, 3.
3, 3, 3.
M plus 3. M square. Minus 3 M.
Yeah. I like it. So 1 M there, 2 M's there. 1 3 there, 2 3's there. 3 times M is there, it's opposite sign. All right, 1 of each, 2 of each, product in the middle. Boop, boop. Sorry. And then on the bottom I got this, so what happens? But what else do I got? The 2 thing.
You have the 2. 2 and M plus 3 on top.
No. So the 2 and the 4 were
Oh,
used.
cancel out.
Yeah. So I got that 2 on the bottom, I got this, and of course these just cancel, so I end up with M plus 3 over 2. How's that so far? Is that right? All right. By the way, I'm going to talk to them. Is it just me, or is this room warm?
Yeah.
It is warm. It feels good? You like it? All right. It might just be me. I'm running around up
It
here.
was warm yesterday.
Today it feels fine? So it's just me. Let me show you on part C, if you're someone who needs help with organization, what you can do, and also this makes it a little easier to look at, because this is like a lot to look at once. And to be honest, the people that do really well at math are the people that kind of naturally are able to break stuff up into parts, right? Because that's what our math is all about. This is 4 different problems, and each problem by themselves are pretty easy, if you know how to factor, right? That whole problem altogether looks like, holy shit.
Yeah.
So if you're able to break stuff into parts, then you're able to do a lot of math a lot quicker. So if I look at this first part,
6y.
yeah, it'd be 6y. You can do a GCF,
A minus B.
A minus B.
M minus
Then I look at this next part down here.
B. We take A.
Take an A out.
I take 1 minus.
I like
You
it.
can reduce that still, no?
True. We'll do that in the next step. And then we're going to do up here. Now this is the part that had everybody freaking out.
Yeah.
And I don't blame you too much, but how many letters, how many variables are in that expression up there?
3.
There's 2 variables. 3 terms, 2 variables.
Right.
So the middle term will be a mixture of them. But all I care about when I start to factor are the coefficients, right? When I factor, it's all about the numbers, not the letters. So what do I do since the first number is a 5?
Can't figure it out.
I can't take a 5 out, right? Because it won't come out at 6 or 1.
Actually, I've done the
5 times
bottom,
6.
so I got the hand to open the upper.
Oh, I like it too. If you do the bottom first, let me do this. I want to make sure everybody's able to do this. 5 times negative 6,
30.
negative 30. Factors of negative 30 that make negative 1, right? You see negative 1 here?
5 and 6.
Yeah, 5 and
Negative
6.
and 5.
Good, I like it. And then you would, let me do it up here. You would take the middle term and make it into minus 6ab. You see where the ab is coming from? You got to make the middle term, it's negative 1ab. So you got to use those variables in the middle term. Minus 6ab plus 5ab minus 6b squared. So all I did was I took that minus 1ab and I split it up into those. How we doing?
Bigger eraser.
Uh-oh. Is that all right? You guys, some of you guys look concerned. I like how you look concerned and you're shaking like, it's okay. So all I did, again, here's what it looked like to begin with,
5A. Yes,
right? So minus 6b squared. And I just took this middle thing and I broke it up using the numbers I found there. Right, it's a surefire method.
What if you flip those two numbers?
It'll still work,
It would?
totally. So why did I put this first? Because it's a negative. And the negative in the middle always is able to mess me up easier, so I don't let it. But if you flip them, it's still going to work. Those are the two numbers that will work for grouping. It doesn't care which way you put them. You're guaranteed to work, and that's one reason why it's called surefire method. Because is surefire going to work? So what? And then you group the first two. Right? What comes out of there? A.
5A.
5A minus 6B.
6B.
And what comes out of the next group?
B.
B.
Yeah.
5A minus 6B. So I know I'm on the right track.
You put together A plus B.
Yeah, so now I can write that as A plus B times 5A minus 6B. So this work here. So this is a little bit, obviously, I'm just trying to use the space on this paper, but you can take a piece of this problem, put it aside, and work on it by itself. So you're not like rewriting all this stuff over and over and over again. You can totally take apart a problem, do it over here, work it out, and then put it back in. That's a beautiful way to do it.
Factor out a 2 on the bottom.
Yeah, on the bottom now comes a 2.
5A, yeah.
So now you can start to kill things, right? Well, I could, but what else can I still do?
Factor out the A squared.
Yeah, the a squared minus b squared can go. Oh, you like this problem, don't you? Like, good Lord, does this problem ever end? 6y a minus b over a times, how do you factor a squared minus b squared?
A minus B times A plus B.
Times a plus b, I already killed these, over 2. So then what else dies?
Kill the A plus B. A minus, and then A minus B.
And one last thing.
And 6 and 2.
So what's left alive?
3y over A.
3y is left alive here. Oh, sorry. Sorry, go ahead.
Can you put the paper down a little bit? That 6b squared. Oh, I got it. Right there. Okay, sorry.
Sweet. All right. And then 3y, and then over a. Bam. All that mess became 3y over a. Sometimes people are upset that it becomes, and me, I love it. It's like, oh, a lot of crap went away. That expression is the same as that expression, so this is a much better expression to use. How are we doing there? Is that all right? Now, I do want to say something about what Ahmed just said a second ago. Let me focus on one piece. I'm sorry. Where are we at? Sorry? 3y over a. Yeah. Real quick, what Ahmed said is really smart. If you look at just this piece, if you do the bottom first, so if some of you guys get this beautiful, you can use this. Do the bottom first, you get 2, 5a minus 6b, right? So I'll bet you anything 5a minus 6b is part of the top. So now watch. If you don't get this, it's okay. You don't have to do this. So I'm going to put it down there, but then I'm going to say, what do I have to multiply that by to get this? What do I multiply 5a by to get 5a squared? A. What do I multiply negative 6b by to get negative 6b squared?
That's B.
B. And then I just check the middle term. Negative 6AB plus 5AB is negative 1AB. So that's correct. I got to make sure that it actually is
Now,
right.
can you do that all the time?
If you have a hint. You see, so what started me off was this hint.
But is that hint always going to be?
No.
Yeah.
See? So that's up to you. You can use it or not. I don't care. And part of me would rather you not, because then you get more practice actually with the factoring method itself. But this is beautiful. If you can use that, I got no problem with that. Exactly.
So what was the final answer then?
Oh. Where is it? Here. 3y over a.
3y over a?
Yep. Because the a was left on the bottom.
How many questions are on the quiz?
My quizzes normally have about 6, 7 questions, maybe.
So is it,
Oh,
is it
two
all
right
over
there.
you, or is it like everything that we just looked at?
So the quiz, focusing on factoring mainly. Yeah, so but it's on the review too, a little bit. So most of the questions will be on factoring. So what will the other questions be? I don't know, we'll find out tomorrow.
Wait,
It could be anything from the review. Oh, shice, that's a lot, Jack. I'm sorry, I'm being really evil, but I'm a math teacher. Say again? Normally about 6 or 7 total. I hate it when a teacher says there's 4 problems, but they each end up being A through J or something. So when I tell you, like my tests are normally, well, for us they'll be a little longer than normal. Maybe they'd be about 28, 30 questions long. And when I say that, I mean that's counting all the A, B, C, D and stuff too, right? Not 30 problems with A through F.
Yeah, that's just evil.
That is evil, thank you. Because I had a teacher that did that. How many problems? 3, and they were all A through Z or something. Yeah.
So we only set them equal to 0 when the first number is bigger than 2, right? That's like a review question.
Wait. Set them equal to 0.
Yeah, it's not even on this. It's not even on this.
But
Set the equation equal to 0.
oh, when the power.
Yeah.
When the power. So, yeah, if I have this problem here, right? I'm not going to set that equal to 0. I'm just. You guys with me? I mean, this is an easy problem to solve. Are you with me? So, the one thing I could do, if I did this, now I got to set it equal to 0. That's the key. Because why? Why is that? Because I can't put all my x's together, can I? Because now I have a non-like x term. X squared is not like x. They're not like terms. So I have to have another way to solve it then. Because why does this work? If I take that away, why does this work? All my x terms, I can eventually put them all together. And then divide by the coefficient, right? Is that cool? The minute one of them is squared or cubed or something, I can't do that. I've got to have another way to solve it. And thank God we do have another way to solve it. How's that? Fewer shaking heads. Damn. We're not cool with that? Is that? I'm trying to give you, this is a, I don't teach triggers, but now that we've talked about it, that's the trigger. When do I know to set a problem equal to 0? When I see a higher power than 1 on any of my variables. I set it equal to 0, and then I factor.
Otherwise, you would just leave that and move everything over and just solve for it.
Yeah, so if I had x plus 4x plus 4 equals, let me do this, plus 3 equals negative 1, right? If I had this, how would you solve that?
Add 1 to make it equal to 0.
No, you don't. Why do you not make it equal 0?
X
I'm going to make 0.
minus 3.
That's what? 5x plus 3 equals negative 1. Subtract 3, 5x equals negative 4. Right? I just have to get my x's on one side, my numbers on the other. I can get my x's together on one side because they're all like terms. Now, almost the same problem. Right, so x equals negative 4/5. Here's almost the same problem. But I can't do what I just did, can I? Because I can't combine these. So I can't do what I just did. So when you see a power on a variable that's different than 1, so for us, higher than 1, we have to get it equal to 0. So what's my first step then?
Add the 1.
Add 1 so I can make it equal to 0. And then what do I do? Factor. And then I get x equals negative 2. Twice, but it's just one answer. You guys with me? Does that make sense? Because remember, you did a lot of solving of equations without ever factoring, right? Back in the day when they all were just x. But now we know more. Now if one of them's not x, and if one of them's x squared or x cubed, we know what to do. Set equal to 0 and factor. Okay, cool. All right. So any other questions from this?
Yeah.
Should we try? Huh?
Can you do the bonus?
Oh, so the bonus, like I said, I originally had cubes, and then I decided to make it a little bit easier, and then I forgot this would have been for the cubes. So that's my fault. That's 6 cubed. So if you change it to 36, it's for the squares now, right?
So go ahead and solve that.
So here, you ready? All right, let me write it again so I got more room. So here's 25 times this thing squared minus 36 times this thing squared. I like it. So the problem says factor this, so the completely wrong thing to do is to start foiling things out. That's the backwards. So what is 2x minus y?
5?
No, I mean, I like that. What is 2x minus y? The correct answer is, I don't know what 2x minus y is, Jeff. And you're like, that's the correct answer? That's never the correct answer. It's totally the correct answer. I don't know what the hell 2x minus y is. So in algebra, when I don't know when something is, I can call it a letter. Right? This seems like it's cheating, but it's totally not. It's the basis of algebra. What is 2x minus y? Let me call it m. See? What is 3x plus 5y? I don't know. Is it m? No, it's different. So let me call it b. Alright, now what I really want you... I know you guys are like...
What'd you just do?
Yeah, I'm confused.
What did I
What
just
did you
do?
just do? What did you 25 and
So,
square?
two things. You ready? Do you notice how many terms are in the problem? 2. There are 2 terms in the problem. Is everything squared? Yes, 25 is 5 squared. That's that thing squared. That's 6 squared. That's 3x plus 5y squared, right? So it is a difference of squares. So the form is a squares. So 2x minus y squared is the square of something. So just to make it look better for a second, this is a middleman. It's called substitution method. I replace 2x minus y with m. Why am I allowed to do that? Because whatever 2x minus y is, I could call it m. Do you guys? If I said I am 5 years older than Frank, well, what can you call? Do you know how old Frank is? No. So what can you call it? X, you can call it Y, you can call it B, you can call it happy face, you can call it, who cares, right? You can give it any letter you want to. So what is 2x minus y? I don't know. The same way we didn't know how freaking old Frank was. So what can I call 2x minus y? M or B or W or whatever the hell I want to. I know that feels like cheating, but it's not. Because this says the same thing as that. What does that say? 25 times something squared minus 36 times some other thing squared. What does this thing say? 25 times something squared minus 36 times something else squared. They say the same damn thing. Now, here's the thing. If you do this method, at the end you have to replace m with what it was to begin with. So let me try this. Let's do this, and then I'll show you how to do this without actually bringing m and b. But that looks a lot better, doesn't it? That problem there, that would have been the problem I gave you. That would not have been worth a bonus. That would have been a normal problem. That's not a bonus problem. How do you factor this?
5m
5m.
minus 6b. Yeah, and 5m plus 6b.
Well, what's m?
And it is
What is m?
2x minus y.
Yeah, m is 2x minus y. And what's b?
3x plus
3x plus 5y.
That's
Whew. And then what's m? 2x minus y. And what's b?
plus
3x plus 5y. You see all that crap? So just the substitution is a way of saying, instead of writing 2x minus y, let me just write m. And that represents whatever 2x minus y is. It's a way of just keeping the idea of the problem the same, just making it quicker to write. That's all. That's all it is. As long as at the end you bring back what the actual original problem wants. If I say this is my answer, the people are like, I didn't ask no freaking m. What the hell's wrong with
key
you?
off the side, it says that m was equal to 2x minus y.
Yes.
So if I put the keynote, if you will,
Sure.
on the side,
I love it. So
Yeah.
that's what m is and that's what b is.
right, and then I can leave it as the m and b at the bottom.
Now, real quick, I don't know, some of you guys might realize you don't need m and b, especially on this problem, because this is the last thing I'm going to say. This is more time than I wanted to spend. But I
elimination method.
like the question. What's that?
I said You said something about substitution. Does this use elimination method or?
No. This is substitution because I'm substituting 2x minus y with m.
Oh, okay.
That's why it's called a substitution method. It is a substitution method. Real quick, I want to see if you guys see this. I don't really need them because how do I factor a difference of squares? Always the same, no matter how ugly it is. Half of 25 is 5. Half of this is one of them.
Yeah, those ones.
Half of 36 is 6. Half of this is one of them.
Yeah.
Blah, blah, right? And I said the same thing in the next one, which is what I got before. So the substitution method just makes it easier to look at in the middle, and then you bring back in what the actual stuff was. So this is the flexibility in math that you don't even know exists in math, because you don't get to see it very often.
So is the answer that one plus what you're going to put in the next one? Or
The
you have to
answer would actually be distribute, get your like terms together. Yeah. But that's the important step to get to is this. You got the same stuff in here, right, with a plus in the middle, right? That's how squares works. So you distribute, get your like terms together, and then you're finally done at the end. Yeah. All right, but that was a bonus again. Eh? But it's an interesting method you could use in certain situations. And again, it's a bonus. So if that's the only thing you had trouble with on this paper, then you're in the right place. You're fine. Right? All right. Can somebody, thank you, somebody, yeah. Oh yeah. We're crazy. We're all crazy. Sign up for a 3-week course. We're all crazy. Yeah, the reason I'm not using that book is they haven't updated it for the new book we have. So that's why that's different. This is differently ordered with different kind of problems. Yeah. So, if you took 103 before and you had the lecture book, I don't know if you guys, like in Math 90, we had the lecture book. Remember the little, was it blue book or green book?
Yeah.
Yeah. There's also one for 103. They just didn't have it ready in time for us. They have to update it for the new book. So I don't know if you knew that those existed. They're kind of nice and useful, but they just didn't have it for us. So I'm sorry. All right. So we've done section 7.1. We've done section 7.2. So now we're going to do 7.2. So 7.1 is all about reducing fractions, basically, right? And the bottom can't be 0. 7.2 is all about multiplying, dividing fractions. So obviously 7.3's got to be about adding, subtracting fractions, right? Or rational expressions. So I'm going to do 7.3 and 7.4 are the same thing. 7.3 focuses on if they already have the LCD, and 7.4 says what if they don't have the LCD. And we know what to do. We just have to realize we do the same thing even if there's variables in there. We do the exact same thing. So let's start with like denominators. This would be section 7.3. Yeah. So recall. If I have 4 ninths plus 5 ninths, I get... Yeah, I get 1. I get 9 ninths, I get 1. I don't get 9 eighteenths, right? Why would somebody write 9 eighteenths? Because they added the bottoms. That doesn't make any damn sense. I have 4 of these plus 5 of these is 9 of these, not 9 of something else. How the hell would that work? 4 chairs and 5 chairs. Now I got 8 watermelons. What? David Blaine shit right there. David Blaine. Anyway, chairs. Anyway, so now we're going to have numbers, but they're going to be numbers we don't know. We're going to have variable expressions. But still, it's going to be like 4 over x plus 3 plus, what you got, Jeff? Oh, not Jeff. 2x plus 2 over x plus 3. Is what?
2x plus 6.
Yeah, 2x plus 6. Over x plus 3. Looks good so far.
And you factor the
Good.
2.
So at the end of a fraction type problem, if it's numbers or if it's variables, you have to see if it'll reduce. And how do you reduce correctly? You factor. So what part of that can factor?
To take out.
Yeah, take a 2 out and I'm left with.
X plus 3.
So it's a little freaky. No matter what you make x, except of course, negative 3. Anything else you make x, the answer will always be 2. So if you give me an x, it's not negative 3. Give me an x. 5. So it'll be 4 eighths, right? If x is 5. Don't write this down if you don't want to. 4 eighths plus, what is this if x is 5? 12 eighths is 16 eighths, which is 2. So no matter what number, except negative 3, because that would freak it out. Pick x equal 18 million, it'll come out to be 2 at the end. How we doing so far? I like it, cool. So that's not bad. When the bottoms are the same, the only thing you have to be careful about is reducing at the end. There's a lot of work already done for you. The LCD is the ugly part normally. If they already are there, if they already have the same bottom, you're like, thank God, let me just add the things together. Let me see. So the freakiest 7-3 can possibly get. I don't know, how freaky could it? Oh, okay, here we go. Here's the number one mistake people make in these kind of problems. Is, of course, it's got to be related to 0 or negatives, right? And it's the negatives, it's minus. So if I have this, become a 2.
That's your y minus 7?
Yeah. Poor little dude. Thank God at some point I started putting a little line through my 7. So hopefully it looks more like a 7 than that. So this is the biggest mistake people make, is related to this somehow, right? So the biggest mistake people make is to say that this is 8 minus y plus 4 over 2y minus 7. So if you already wrote this down, you're wrong. I'm sorry. That's not right. It's not what it says.
So
Do you see why that's not right? What am I subtracting?
The negative makes the y minus.
Subtracting both of these. Not just the y. I'm subtracting. So what I say to people is to do this. I don't know if you remember way back when you had like negative 2 minus 4. You can make this plus negative 4. Remember those? So if you make this plus negative, maybe you'll remember to distribute the negative. I don't know. So you just got to remember to distribute that negative through. You guys kind of with me? A little tiny bit. Because this, you're saying you're subtracting just the y. But this originally said subtract this whole thing. So you have to subtract the whole thing. So now this should be a negative 4. Because you distribute the negative, bam, bam. And of course you get 4. And can you do anything else with this besides write it better? No. Come on, why? Rah. That's obviously not going to reduce, right? Neither one factor, so you're done.
But what was the original problem?
Oh,
I didn't look at it. I didn't see
the original problem was that.
Okay, and then you just added the plus and...
Yeah, if you want to, or you just got to remind yourself this has got to go to both of those. That minus has got to distribute because you're subtracting all of it, not just the first part of it, right? Because otherwise, if I wrote this as 4 plus y, I could do that, right? It's the same as y plus 4, and then the 4 would be negative and the y would be positive. No, if you just do something legal, it can't suddenly change the whole problem. That's not allowed. I'm subtracting both of these. They both change signs. So that is the one place to be careful about. There's a minus sign in between your fractions. You got to stop and go, holy shit, I got to be careful.
So the whole thing changed on there, not just the y.
Exactly, it's got to. Because I'm not just subtracting the y. I'm subtracting the y and subtracting the 4. You guys see that? Minus y minus 4. Bam. I mean, it's the same thing as if I said 7 minus 5, that should be what? 2. If I rewrite 5 as 4 plus 1, I have done something wrong. Because what is that now? 7 minus 4 is plus 1 is 4, not 2. Well, so that's what I did wrong, isn't it? Do you see that? So it's sort of like, I can't combine those. I can't put y and 4 together, so I can't do something like this is easy. Now that's, but I can't combine 4 and y, so I just got to remember there's 2 parts to this. That they both have to get a negative. I can't make it a single number, so it's not as easy. Maybe. I don't know. I can't read you guys. Like I say often, I don't want to play poker with most of my students here. I have no feelings about that. It's scary. All right. So that's the one big thing to be careful about, is if there's a minus in the middle. That's really the only thing that should throw you off in section 7.3 is that. Otherwise, section 7.3 should be easy. All the bottoms are already the same. Holy crap. Yes, give me a bunch of fractions like that, right? So, let's talk about the big bad thing about what if the bottoms are not the same. So, become a 7. Unlike
So we just finished that.
denominators, right? And I don't mean uncheck the like button on the denominator. 2 denominators that are not the same.
Everybody does their Facebook page.
Alright. So let's remember, and let me show you a method that very often you don't have to do because the numbers normally are pretty easy. But let me show you, what if you had this problem from before, from way back when? 4 over, what you got, Jeff? I don't know, man. You could do it. Can you do it? I don't know, Jeff. Well, let's just make it, no, I'm sorry.
X.
Yeah, that'll work. 27 minus. Yeah, this will work. 5 over 72.
That's not a negative down there, right?
No, that's
Oh,
right.
okay.
It's just a smooch. All right, let me stop there for a second. I really don't want to do like 27, 54. You remember that process, and then you see if it matches up with that. So here's the much better way to do this. If I had 4 ninths minus 1 18th, sorry, that's easy, right? Or even if I made it 1 15th, that's not too bad, right? I don't know if you guys, but the minute that even this is not that easy, to be honest, not as easy as it could be. But this, now watch what I do. This is kind of nifty. The whole idea of LCD is to give what the bottoms, what they're missing. Give them what they're missing so they're the same as the other one. I always call it like 2 kids with ice cream. He got more than me. Okay, he got more than me. And you just eat them all. Which is why I'm probably good I don't have kids. Just give me all the ice cream. What is the biggest number these two have in common? 9. Good. Right? You have to be able to do that to be able to do what I'm about to show you. So break them down using that number. 27, break it down. 9 times 3.
8.
9 times 8. Now it's really easy to see what they're missing. They both have a 9, but what is this guy missing? 8. So you give it to him. I'm allowed to give it to him because I got a top and a bottom. And what's this guy missing? 3. Has anybody ever seen that method before?
Yes.
Especially those of you that had me. That's the way I teach that. I like it. So you guys have seen the method before. A lot of you guys. Beautiful. I love it. And then that makes it really easy. It's just give them what they're each missing according to the other. Right now I got 2 happy kids instead of 1 happy dad. Right? 32 over, what's that? Uh, 246.
209?
209?
No?
No. 24 times 10 is 240 minus 24 is 216, yeah. 216? Yeah, thank you. Minus 15 over 216 equals 17 over 216. Alright, cool. How are we doing so far? Alright, so it sounds like a lot of you guys already knew that. I love it. Kick ass. More and more people need to know this method because it works beautifully. And it's also the way you want to do it with variables. When I have variable expressions, I have to do it this way because what did I do to 27? I factored it. So if I break a variable expression into its parts, I can see who's missing what. very easily. You all right? You sure? All right. Sorry, don't mean to single you out. Just looking at all my confused faces that aren't saying anything.
Is it possible to simplify it first, like 4 with the 27, we take 4 and down, like we say 7 by 4 and...
Careful, 7 and 4 is 28. But if it was 28,
yeah,
then you
but
could- if it was 28, of course, yeah.
yeah.
Cool. All right. So if I have variable expressions in my denominators, let's see, like, gotcha. Let's see. Yeah, no. So the idea is exactly the same. It has to be the same because these are all numbers. And so are the ones we just did. They're all numbers, so they have to be the same way. They have to work the same way. So how do I factor this guy?
X minus 4, X plus 1.
And how do I factor this guy?
Look at it, guy. No.
Careful. It's not a cube.
2 and minus 4.
You just need two numbers that multiply 8, add to be negative 6. Minus 2 and minus 4. So what do they have in common?
Minus 4.
Yeah, so what I always get, always, without fail, is somebody cancels these. What in this problem tells you that those would cancel? Several problems. That's a minus. That's a plus. Good job, Jeff. That's a plus, not a times. So even if they were on the top and the bottom, it's adding, not multiplying. You can't undo division. But even as bad, they're on the same level. They're both on the bottom. So even if it was times, they couldn't cancel because they're both on the bottom. Are you guys with me? But somehow people always kill them. I don't know how. All right. So the right way to do this, they have to stay there, but now you just give them what they're missing. What is this guy missing? He's got
X minus
x minus 2. So you give him x minus 2. What is this guy missing? And he's got x plus 4. So you give him an x plus 4. Now, do they both have the same bottoms? Yes, they do. So you're allowed to add them together then. Yes, sir.
What I always do say is writing time. Could I just write, like, as long as I define x minus 2, x minus 4, x plus 4 as LCD, and then just, because I always would just write LCD underneath.
Oh, sure,
and
sure.
Then at the end,
Yeah,
plus.
sure.
Okay.
Yeah, trust me, if you do it differently and you like the way you do it and it makes sense, you don't have to do it this way. To me, though, this is the way I always teach it, because this is the way that makes the most sense to me. But if you have a way you do it that makes more sense, beautiful. I love it. You don't have to change your method to be the same as my method.
So pretty much that's the whole denominator right there.
I love it. So that's going to be the bottom. So we've got the bottom set. The bottom is going to be x minus 2, x minus 4, x plus 4. Now, one big mistake people make. Don't write this. Next part. Don't write what I'm about to write, because I'm going to erase it immediately. If you left this like this, if you left it like that, people then cancel that and cancel that. Why are you not allowed to do that?
Because right now you're
It is not multiply.
It's not, yeah, it's plus. Division can't cancel parts of an addition. It doesn't, that's not its job. It can't do that. And it's like saying you didn't really need this. If it just cancels immediately, why did you need it? Right? So you needed it. So what I tell people is don't even let yourself have that option. Distribute first so you don't even see it there. Right? So you get
3x squared minus 6x. 2x plus
cool. So I get 3x squared.
Minus
4x.
Minus 4x.
Plus 4. I mean 8.
All right, thank you. Wow. And then you should try to see if this factors,
And then that's when we...
and it won't. Good. Because you get 24, and there's no factors of 24 that make negative 4. So it won't factor, so you're done. But you have to check to see if it'll factor. See if something might cancel, but nothing does, so you're done. You're done. it. Cool. A little review, what could x not be in this expression?
2, -4.
It can't be 2, it can't be -4, it can't be 4. I like it. Cool. Yes. I like it. Cool. Okay. So it's not that bad. It really isn't. And again, though, if you don't know how to factor, you can't do any of this. It's all based on your ability to factor. If you can factor, chapter 7 should actually be relatively easy. If you can factor, that's the big step. So let me give you guys a few to try. Let's see. So everybody got this here? All right. So you guys try this. Try these. If you want to work together, feel free. Let me see. Let me just steal some out of the book. Give my brain a break. Yeah, let's do that. Oh yeah, I know what this is. Yeah. All right. Now, last one, I made it myself, so I know there's something kind of weird there, maybe. Be careful about. Those three, simplify those, would be the instructions.
Before we move on, I just had a question. Yeah, there's like a few of those, but there's one.
Well, this one, real quick, you could take a -4 out. Do you see that? I always do GCF first. And I would take a negative out because if that first number is positive, it makes it easier.